Hi everyone, so this video is about clarifying the difference between softmax and maxout as hidden layer activations. So we discussed softmax as an output unit, right, when pairing it with the cross entropy cost function. Now let's discuss what it would do if used as a hidden layer activation. So basically softmax will select, you will select multiple units in one layer, and then you apply the softmax function on them, and softmax would basically do this, right? So it would take, so for every value it would exponentiate this value and then normalize it by the sum of the exponentials of all the considered unit in the softmax activation. So what happens is that when you exponentiate, you increase, or you make the difference between the maximum value and the rest more pronounced, and that's why there is an analogy between softmax and the probability distribution of selecting the most likely class, right? Because of this normalization, and because you select the maximum value and you set it approximately to 1, and the rest becomes approximately to 0 because of the exponentiation process. Now, this looks similar, and that's why we are having this video. This looks similar to maxout in a sense that maxout selects the maximum value of its inputs as well. Okay, but let's see what are the differences. So softmax, when pairing with cross entropy, it's fine. It looks fine with gradient based learning, right? Because actually the word soft means it's a continuous differentiable approximation of the maximum. So this is good for gradient based learning. And also because cross entropy has a log function and it undoes the exponential, so that you get linear behavior and you get the desired consistent gradient behavior, right? Now the exponential by itself, if you use softmax as a hidden layer activation, this is difficult to optimize because it has the gradient direction is not consistent at all, right? So the exponential goes up very quickly, right? And so for example, if I have here an exponential function, it looks like this, right? So the gradient here looks like this, the gradient here looks like this, the gradient here looks like this, and so on, right? So the gradient direction changes very quickly, right? So this is one clear difference from maxout. Maxout is a piecewise linear function. Here, this is an exponential function. Actually, the other difference is actually much more fundamental. This is related to optimization, right? But the other difference is that they are, although they look similar, they are actually delivering fundamentally different functionalities, right? Maxout selects the maximum value. So if I have a maxout function with certain inputs, right? It selects the maximum out of these inputs, and then that maximum is then connected to the next layer in a certain way, right? So whatever maximum I'm selecting, I'm only taking the value, and then the connectivity remains the same, right? Softmax is not doing this. Softmax, I have as input multiple units. Each of these units have different connectivity to units in the next layer. And then I enable one of these units to be active right now, right? And the rest are disabled. They are not learning. So I am enabling part of the network related to the unit that's selected as the maximum, right? And then I take this unit with its connectivity to the rest of the network and I enable that, right? Max out, the connectivity to the next layer is fixed, no matter what the maximum value is, right? So that's why, because of this functionality, that softmax is typically used for very special neural networks, and these are neural networks that use explicit memory, right? So neural networks that manipulate explicit memory. And one of the projects in this course will be on neural networks that use explicit memory. And you will see in the project that it's very difficult to optimize these neural networks. By explicit memory, we mean it's more similar to how we function. We consciously recall things, right? So there is a memory where we store things and then we recall these memories. right? A normal neural network or the typical neural network, like a convolutional neural network or any kind of the common ones, the memory is implicit. Even the ones that are recurrent, like if you heard of LSTM, which we'll have discussed later, long short-term memory networks, these networks have implicit memory. It's not explicit. Now, so if you want to think of how softmax is working as a hidden layer, think of the attention mechanism that we human beings have, right? So when you watch a movie, for example, you watch a scene in a movie, it reminds you of something, right? It reminds you of some memory. Then you consciously recall this memory and reflect on it, right? So as you're watching that movie, and it reminds you of that specific memory, you are learning only part of your brain that's related, that has functionalities related to this memory, is now learning, and the others are not. For example, if I see some movie, it reminds me of some memory that I had 10 years ago, and I'm reflecting on that memory, maybe changing my belief system, but that is not related at all to, for example, the way I drive, right? This is another part of my brain, and that part is not activated right now. It's not learning right now. That's what softmax is doing, right? And this is why it's used in networks with explicit memory. Maxout, the functionality is completely different, right? Maxout is a variant of rectified linear units. It's just a way of selecting one of the inputs. It's not an attention mechanism. It's not a switch, right? The other major difference is it's clear, we discussed with Maxout how to use it with overlap to avoid catastrophic forgetting, right? To overlap between the units. It's not clear at all, and this is kind of an open thought exercise, how to use softmax with overlapping the units. For example, how to take a set of 10 units, apply softmax on them, and take only a subset of them with another subset of other units, and apply softmax on that subset, right? So these are basically the major differences between softmax and maxout as hidden layer activations. Thank you.